How are you? So in this video we would be discussing about rotational motion. So before that, just to remind you all the formulas and symbols. See, in translational motion we have here S, that is the displacement, velocity V, and acceleration A. So we say this car moves with u velocity, reach V final velocity, and moves a S displacement in time t. So these all questions we have done in kinematics. So in rotational motion, in circular motion, first of all, in circular motion, we have different symbols for this. First of all, this S, that is the displacement, becomes theta here because this particle from P reached to Q. So we say that this much of theta has been covered by this point. So if this point is now moving like this, so this particle has a velocity. We call it an angular velocity, that is omega. So we will write it angular velocity. And when we have a velocity and direction is keep on changing, or if the magnitude 2 changes, there is an acceleration. So that acceleration becomes alpha, that is angular acceleration. So to relate all these, we have formulas. So the S becomes r theta, V becomes r omega, and A becomes r. So if like the angular acceleration is given to us, and if we multiply it with the radius by which it is moving, it changes to the translational acceleration, similarly to the velocity and displacement. Apart from this, we had also learned about the Swatt equations. So we have like V equals to U plus AT, S equals to UT plus half AT square, and V square equals to U square plus 2AS. So these equations too get converted while the using in the circular motion. So this V is the final velocity, so it becomes the final omega, and omega naught is the initial velocity, plus A becomes acceleration, that is the angular acceleration, and T. And this S becomes theta equals to omega naught T plus half alpha T square. And this becomes omega square equals to omega naught square plus 2 alpha, and S is theta. So these Swatt equations are also applicable in circular motion. So with this is the major part in the circular motion. But our topic is rotational motion. So what is basic main difference in rotational motion and this circular motion? See, in circular motion we have just one particle here. We are saying that this is a string and this particle is moving like this. Whereas in the rotational motion we have a rod like this. So this rod can move like from this axis also, from this axis also. So it would be moving like this. So not like this. Yeah. So it would be the whole of the body will be rotating. So before we reach to go to this concept, first of all we would be discussing about the torque. So torque is very important in circular motion and rotational motion. So basically, like we know that if there is some object here and we put some force here, up to this knowledge, we know that this object will move like this and this will reach here, and there is no friction, there is nothing else. So this object would be moving, and we will say that F equals to ma. So this we have already done in the force part. But torque is like, suppose there is some shaft here. When we put some force F, it moves downwards like this. Or we have door at home, we do have doors, and when we put some force F, this door get closed or door get opened, and we have a hinge here. So this is a torque. So torque is basically, the formula for torque is R cross F. So torque is not a force, but ability of force to rotate the object. So this torque is a very important concept in rotational motion. So just take care for that. We will do a little more into torque. So like if there is force like this at some angle, and this is R, so you would be taking this component R cos theta, and this will be R sin theta. So the torque here would be R cos theta into R. So it should be 90 degrees here. And the torque by this force would be 0 because the axis is all parallel to it. So there wouldn't be any torque. So torque by F sin theta and into R. So there will be a sine function here, sine 0, because it's a cross product. So it will become 0 here. So whenever there will be torque, you have to take this, that the force should be 90 degrees to the radius. After that, there is another concept of equilibrium. So in the equilibrium, there is two types of equilibrium. One is the translational equilibrium, and another is the rotational equilibrium. So translational equilibrium means like the body, the center of the mass is not changing. Like suppose there is one person here is sitting here and another person is sitting. The two forces are downward, and this would be putting some force in the upward direction, whereas the center of the mass is here. So center of the mass is not changing. So if the center of the mass is not changing, then we will say that it is in the translational equilibrium. So in that case, like this, F will be equals to F1 and F2. So the summation of F will be equals to 0. So F1 plus F2 minus of F will be 0, because like downward it is positive and upward it is negative. This sign convention is up to us. We can take it like positive negative or negative positive. So this will be the equation for translational equilibrium. Now if we talk of now rotational equilibrium means like if there is a disk and this disk is not rotating. So one, we are putting force here also and here. So two of the forces are countering each other. So one force is clockwise and other is anti-clockwise. So you can take it like clockwise as positive and anti-clockwise as negative. So it all depends upon us. It is not a rule that you have to take clockwise negative or positive. If you will take it positive, it will another will be automatically the opposite of that. So in this case, there is the net torque will be equals to 0. And net torque, suppose how you will calculate. So this is the radius. If force is this, so you will say that F1 R1, because R will be same. So it will be like suppose like this. So F2. So you will say that F1 into R minus F2 into R will be equals to 0. So if there is no rotation, this equation will be there to solve the question. And then there is another concept that we would be doing in the next video, and that would be the moment of inertia. So that's also very important concept. So see you in the next video. Hope this video was helpful to you. Thank you for being here.